Hello viewers, in today's class we are going to discuss another problem from integral inequalities, right? So in this lecture we'll see a very important problem from estimation of integrals, in which we are given an integral I is equal to 0 to 2 pi, and we have dx over 5 plus 3 cos x. Then we have to show that the value of this integral I, it satisfies this inequality, that is I is greater than or equal to pi by 4 but less than or equal to pi, right? So without evaluating this integral, we have to arrive at this inequality. So let us start. So viewers, whenever we have to estimate integrals or we have to solve these kind of problems related to integral inequalities, we usually make use of different identities related to integrals. But here, to solve this problem, we'll use an important concept that is called mean value theorem for integrals, right? So mean value theorem for integrals is a very important uh, concept to prove these type of inequalities. So mean value theorem for integral says that if we have a function, say y is equal to f of x, and this function is continuous in the closed interval a comma b, then the value of this integral, this function f of x, that is the integral of f of x dx from x is equal to a to x is equal to b, is equal to b minus a times f of alpha, where alpha lies between a and b, right? So now if we compare this integral with this one, then f of x is equal to 1 over 5 plus 3 cos x, and the value of a is 0 and the value of b is 2 pi, right? So the lower limit is 0, the upper limit is 2 pi. So now using this mean value theorem, we can now write I, that is this integral, which is 0 to 2 pi dx over 5 plus 3 cos x, is equal to b minus a. B is 2 pi, a is 0, and f of alpha, right? Where alpha is some number which lies between 0 and 2 pi, right? So now we have this expression. So we can now write I, and here we have 2 pi minus 0 is 2 pi and f of alpha, right? Okay. Now f of alpha can be written by replacing x by alpha. So we can now write I is equal to 2 pi times 1 over 5 plus 3 cos alpha. So we can now write I is equal to 2 pi over 5 plus 3 times cosine of alpha. So now we have this expression, right? Now let us make use of some trigonometry here. So we know that the value of cosine of alpha, it lies between minus 1 and 1. That is, the minimum value of cos alpha is minus 1 and the maximum value of cos alpha is 1, right? And whenever alpha belongs to this interval, that is 0 to 2 pi, right? Okay, now see, in the denominator we have 5 plus 3 cos alpha. So let us multiply this inequality throughout by 3. So we have here minus 3, 3 ones are 3, here we have 3 cos alpha, and here we have 3 ones are 3, right? Now here we have a term 5, right? So what we will do, we'll add 5 throughout this inequality. So we have minus 3 plus 5, 3 cos alpha plus 5, and here we have 3 plus 5, right? So 5 minus 3 is 2, and here we have 5 plus 3 cos alpha, this is 8, right? So using this fundamental inequality from trigonometry, we have arrived at this inequality. So now let us divide this inequality throughout by 2 pi, because here we have a factor 2 pi, right? So what we will get here, we have 2 over 2 pi, then we have 5 plus 3 cos alpha divided by 2 pi, and here we have 8 divided by 2 pi, right? Now here we can cancel the common terms. So here we have 1 over pi. Then we have 5 plus 3 cos alpha over 2 pi, which can be written as 1 over I, right? Because I is 2 pi over 5 plus 3 cos alpha, and we can now write here the reciprocal of I, right? So this is 2 4s, so this is 4 over pi. So now let us take the reciprocal of all these three terms, right? So when we take the reciprocal of these three terms, then the direction of the inequality get reversed. So here we have pi, then here we have the sign of greater than or equal to, then here we have I, and here also the direction get reversed. So we have pi over 4, right? So we can also write this inequality as pi by 4 is less than or equal to I, that is less than or equal to pi, right? So this is our desired inequality which is to be proved. So viewers, this is how, by making use of the mean value theorem for integrals, we can solve these kind of integral inequalities. Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integral inequalities, right? So in this class we'll prove this inequality, that is, we are given an integral I from 0 to 1 square root of x raised to 4 plus 2, and here we have to prove that the value of this integral I is greater than or equal to square root of 2 but less than or equal to square root of 3, right? So without actually evaluating this integral, we have to estimate the value of this integral I between these two numbers. So viewers, here we have to estimate this integral, and we have to show that the value of this integral lies between square root of 2 and square root of 3, right? And here we are not going to evaluate this integral. So we'll prove this inequality with the help of an important result from integrals, that is known as the mean value theorem for integrals, right? So the mean value theorem for integrals says that if we have a closed interval, say a comma b, right, and we are having a function, say y is equal to f of x, and this function is defined on this interval, and it is also continuous, right? So mean value theorem for integral says that the integral a to b f of x dx is equal to b minus a, that is the difference of upper limit and lower limit, multiplied f of alpha, right? Where alpha is some number which lies between a and b, right? So this is the mean value theorem for integrals, and this is a very useful result for solving these kind of problems. So now if we compare this integral with this one, then we can see that the value of a is 0 and the value of b is 1, right? A is 0, b is equal to 1, and f of x is given by square root of x raised to 4 plus 2, right? So using this result, we can now write this integral I, that is 0 to 1 square root of x raised to 4 plus 2 dx is equal to b minus a, right? B is 1, a is 0, so we have 1 minus 0, and then multiplied with f of alpha, right? F of alpha, where alpha, this alpha is some number which lies between 0 and 1, right? So 1 minus 0 is simply 1. So we have 1 times f of alpha, that is equal to f of alpha, right? So our integral I is now equal to f of alpha, and f of x is equal to square root of x raised to 4 plus 2. So we can now write the value of f of alpha by simply replacing this x by alpha, right? So we have I is equal to square root of alpha raised to 4 plus 2. So now our I is equal to this quantity, that is square root of alpha raised to 4 plus 2, right? And now see, here we have this inequality, that is alpha lies between 0 and 1, right? So what we will do, let us take the fourth power of all the terms in this inequality, right? So raising these three terms to the power of 4, we have 0 here, then we have alpha raised to 4, and here we have 1 raised to 4. So this is 0, this is alpha raised to 4, this is 1, right? Now see, here we have alpha raised to 4 plus 2. So what we will do, let us add 2 throughout this inequality. So we have 0 plus 2, alpha raised to 4 plus 2, here we have 1 plus 2. So this is 0 plus 2 is 2, this is alpha raised to 4 plus 2, this is 1 plus 2, 3, right? Now here we have square root of alpha raised to 4 plus 2. So let us take the square root of all these three numbers, right? So we have square root of 2, square root of alpha raised to 4 plus 2, and here we have square root of 3, right? Now square root of alpha raised to 4 plus 2 is I, so we have square root of 2 I, and here we have square root of 3, and this is our desired inequality. So this inequality suggests that the value of this integral I, it lies between square root of 2 and square root of 3. So this is how, by making use of the mean value theorem for integrals, we can solve these kind of problems related to integral inequalities.